All right, guys, today we're going to look at similar figures, okay? Now, the good thing about this is this is very, very simple, okay? It's just like proportional equations. So if you understand proportional equations, this will be a walk in the park, okay? So here's some things about similar figures that we need to know that make these figures similar. So the first one is they're the same shape, but different sizes. Same shape, different size. All right. Another thing is they have proportional sides. So proportional sides. And the last is they have the same angles. So all the angles on the inside of the shape or the figure are the same. Okay? And this means they are congruent. Congruent means the same. And you'll see symbols that look like this. It's like an equal sign and a wave on top of it. Okay? That means they are congruent. Same size. All right. So one thing we use to determine similar figures, and I'm sure you guys have heard this before, is a scale factor. Okay, scale factors. I know if you've ever been to a toy store and you see cars that say they're a 1/64 scale, that means that it is 1/64th the size of the actual car, okay, or truck or whatever it is. Okay, so scale factor. So a scale factor, this is the ratio of the lengths ratio of the lengths of two corresponding sides. Corresponding is basically the same sides. Corresponding sides in similar polygons. Okay, so this is the ratio of the lengths of two corresponding sides in similar polygons. All right, so basically if we have two shapes, we find the same side on each shape. All right, and the scale factor will be from one shape to the other. Okay, that's what your scale factor is going to be. So let's look at a few examples here. Okay, now with this unit, you can't make fun of my drawings. All right, I'm not an artist. I'm a math teacher. Okay, so don't laugh. All right, so let's say we have two triangles, for example. Let's say we have this big triangle here. Oh yeah, this is a nice cute one. And we said this side was 12, and this side was 20. And then we have this little bitty triangle. Okay, and let's say this side is 3 and this side is x. Okay, now here is what your directions are going to say. It'll say the figures are similar. It has to tell you somewhere, forgot my E there, that the figures are similar. If it doesn't, you cannot assume that they are. Okay, don't assume. Let's say the figures are similar, find x. All right, so we're going to set up a proportional equation to help us solve this. All right. Now, again, I'm going to try to use some different colors to help you guys identify how we set this up. Now, you can set this up from shape to shape. Okay. You can also set this up from the same side to the same side. Okay. So we'll do it this first way. I'm going to underline each one of these in different colors here to help you all identify. So we're going to set up a proportion here, which means we're going to have something over something equals something over something. All right. So we're going to do this first one as shape to shape. And when I say shape to shape, I mean we're going to do these sides. So I'm going to have 12 over 20. because this is my scale factor, it's my ratio, okay? And the other triangle, here's what we need to remember. If I started with 12 here, okay, I should start with the same side that I started on the top. So this is 12. That means I need to start with 3. All right, over x. We can't have 12 over 20 equals x over 3. If it's 12 over 20, I have to start with the same one here. Okay, so this is one way to set it up. All right, this is figure to figure. Now, if we look at it from side to side, let's see, I do side to side. And this one was figure to figure. And I know I had to write small. I should have wrote that down earlier. I apologize. So if I set up side to side, I'm going to have 12. What's the corresponding side to 12? It's 3 equals. Now, if I started with this figure on top here, I must do the same here. 20 over x. Okay? Now, this looks just like our proportional notes. Okay, so look at our proportional notes here. What do? We cross multiply. We're going to do the same thing here. Okay, so let's cross multiply. What is 12 times x? It's 12x equals 3 times 20 gives you 60. Now I have a one-step equation. When I have a number and a variable side by side, it means multiply. The opposite of multiplication, division. Divide by 12, what you do to one side, you do to the other. Yeah, good job. The other side. Divide by 12. Only thing that's left here is x equals 60 divided by 12 is 5. X will equal 5. Let's see if we get the same answer here. What's 12 times x? 12x equals, what's 3 times 20? 60. Divide by 12. Divide by 12. X equals 5. Same exact answer, okay? Two different ways to set up our proportion. You have figure to figure, so you can do your side over your side, and then your same side over your same side, or you can do side to side and side to side. Either way, you'll get the same answer. Whatever makes more sense to you, okay? All right, let's look at another example. Again, do not make fun of my drawing, or I will call you out. It looks like all these examples are triangles. So we're going to stick with the triangle theme. Okay, so let's say we have this little bitty cute triangle. It's so sweet. So we have 1 and x, and then we have an even bigger triangle. All right, let's say we have 3 and 9. Now, we're going to set this up. These figures are similar. I've told you that. They're similar. So when I set this up, let's go the hypotenuse, which is the longest side, x over 1 equals, and again, I have to start with the hypotenuse. If I started with that here, I have to start with that corresponding side on this side, equals 9 over 3. Let's cross multiply. X times 3 is 3x equals 9 times 1 is 9. Solve for x, divide by 3, which you to one side, do to the other, and x equals 3. Okay, so similar figures, you set up your figure, okay, just like we set up our proportions. All right, set proportions, you can do it just like we did up here, figure to figure or side to side. Okay, either way you'll get the same answer, and then you solve it just like you do a proportion. All right. So if you guys have any questions, remember you can email me. All right. I'll try to get on Google Meet. Remember your IXLs. Okay. And I hope that you guys find this helpful. And I hope you have a good rest of your day.